Can you not love that? How can you not love that? Anyhow, lesson 1.4, reflections. Let's talk about it. Okay, so let's talk about the formal definition of a reflection. A reflection is a type of transformation in which a geometric figure is flipped over a line, and I can't emphasize that enough. Okay, it's reflected over a line, creating a congruent image. All right? That's all it is right there. So it's just over a line, creating a congruent image. So if you look here, this would be a good example of a, what's it called? A reflection. The line of reflection is over here, P, and ABC is reflected over this line to get our image. All right? Now the big thing about this lesson, I really want you to listen to this, is that, and here's my important, I even put important fact here. To reflect over an object, you must have a line to reflect over. Okay? To reflect an object, you need a line. I can't reflect ABC unless I know what line it's reflecting over. So throughout this lesson, please keep that in mind. We're reflecting over a line. So what's my line of reflection here? Line P. Now the other thing I'd like you to notice is that, and this is really important, the distance from A to my line of reflection, okay, is the same exact distance as A prime to my line of reflection, okay? So if this is, let's say, 6 inches, this is also 6 inches, and if you look here, from C to my line of reflection to C prime for my line of reflection, if this was 3 inches, this is also 3 inches. So the distance from each point to the line of reflection is always the same. That's another point, right? Because this really wouldn't be much of this wouldn't be a great reflection if, say, let's just move this guy over here. Okay, let's move this triangle like this. All right, doesn't that look funny? It's not really reflected perfectly. The reflection always has to be the same distance. Okay, it's got to be exactly the same. All right, so let's perform a few reflections. All right, for our first reflection, we're going to reflect over the x-axis. So read along with me. Reflect line AB over the x-axis. That's AB, and the x-axis, you might remember, is this guy right here. Okay, this is our x-axis. We're going to reflect over this line. State the coordinates of the pre-image and image of AB. Now there is a rule that we're going to use to make this way simpler, and you have to memorize this. Well, you don't have to, but it makes life way easier. And the rule for reflecting over the x-axis is this. You take your coordinates x and y, and what you do is just change the sign of y. That's what that negative means. So let's even write that in words, okay? I want you to write this note down. Write change sign of y. So for all your y values, you're going to change the sign, and the x stays the same, okay? X stays exactly the same. So if we wanted to reflect this over the x-axis, all we're going to do is first write down our coordinates. And if you see here, A is at -6, +3, and B is at +5, +6. Okay? So I wrote down my coordinates, and what I'm going to do is just write down my rule right here. So it's keep the x, change the y. So what I'm going to do is I'm not going to do anything to my x values. X's stay the same. Alright, so x is -6, it stays -6, and 5 stays 5. Now what I'm going to do is change the sign of my y's. So 3 becomes -3, and 6 becomes -6. So that's my coordinates. Now let's check to see if that worked, okay? Let's see if this actually looks like a reflection over the x-axis. Well, A is at -6, -3, so that would be my A prime right here. And my B is at 5, -6, and that would be right here. Okay? And if you draw that line like so, would we say that this looks like a reflection over this line right here, x-axis? I'd say so. And just to check, let's just do a little counting. A is 3 units from the x-axis, and A prime is 3 units from the x-axis. It looks like I'm doing a pretty good job here. Now let's reflect over the y-axis, okay? Same idea. We're going to reflect triangle CAT over the y-axis, and we're going to state the coordinates of the image and the pre-image. Now a reflection over the y-axis, the rule is just a little bit different. You take your coordinate xy, and what you do is you change the x value now. So y stays the same, and we're going to put that note there. change sign of x. All right? So to do our reflection over the y-axis, which is right over here, just to remind you guys, we're going to first write down our coordinates. C is at -8, 3. A is at -5, 8. And T is at -2, 3. We're going to write down our rule. And like I said, it's really helpful if you memorize these things. -xy. And what we're going to do now is change all the x signs. Okay? So look here. So since our x is negative, we're going to change it. Alright? Because it says change the x. And that becomes +8. -5 becomes +5. And -2 becomes +2. And are we going to change the y? No. Y stays the same. So it's still the same. 3, 8, and 3. So let's draw our new points. So A is at 8. C prime is at 8, 3. That's C prime. A is at 5, 8. Okay. It's A prime. And C is at 2, 3. Okay. That's T prime. Notice how I label all my primes. It's really important that you do that. And sure enough, this does look like a reflection over the y-axis, right? All the distances are the same. A is 1, 2, 3, 4, 5 away. And A prime is 1, 2, 3, 4, 5. Alright, and if you checked all the distances, you'd see that they're the same on both sides of the line of reflection. Beautifully done. Let's take it up one more notch though. You might be getting a little too comfortable. Like, that's easy, I can do that, no problem. Yeah, try this. Alright, we're going to take it up a notch. Now for this one, you'll see that we're not using the x or y axis. We're going to reflect over different lines. Okay? Now we're going to reflect point C over the line x equals 2. You got to remember back to algebra to be able to do this. Now, how do you graph this line? We're going to reflect point C over x equals 2. Now the problem is there's no rule for this. Okay? I'll show you how to do it. Well, first you're going to you got to draw x equals 2. And here's a little pro tip if you forgot what that means. X equals always produces a vertical line. Okay, so x equals 2. Alright, if you're wondering what that looks like, looks like the computer doesn't want to do anything. X equals 2 is going to be a line at 2, and it's vertical. So we're going to draw a vertical line at 2. Okay, now like I said, there's no rule. What we're going to do is called the counting method. All you do is count how far C is from the line of reflection. So it's 1, 2, 3. And like I said before, the image is always the same distance. So what we're going to do is count 3 on the other side of the line of reflection. So 1, 2, 3. And that's where C prime is. Okay? So if you look here, all we did was count how far they are, and that's how you get your new point. So I'm just going to erase our little markings. If you look here, oops, C and C prime are both 3 units away, and all you had to do was count the distance. 1, 2, 3, 1, 2, 3. For our next one, we're going to reflect point D over the line y equals -3. Now once again, the pro tip here is if it's y equals, you get a horizontal line. So what you're going to do is this. You're going to go to -3, and y equals -3 looks like this. It's a cross like that. You can just use a dotted line. And what we're going to do is count the distance. So from D to the line of reflection, it's 1, 2, 3, 4. Okay? Now since it's going to be the same distance on the other side, we count again. 1, 2, 3, 4. And sure enough, D prime, that's where it goes. You just had to count. Okay? So they're both 4 units from the axis of symmetry, or the line of reflection. Okay? And that's it. You just draw the line and state the point. Now, I just want to be clear here. Remember this pro tip. X equals vertical, Y equals horizontal. Very helpful. Alright? Now, just as before in the last lesson, you have to be able to perform. Alright? So we were doing translations and we're doing reflections. Now you also have to be able to describe them. So you have to look at one and tell me what reflection took place. Alright? So now we want to know what transformation maps triangle ABC onto XYZ. Where's that line of reflection? That would be right in the middle of these two. It has to be in the middle. Well, in my opinion, and I think I'm right, it would be the y-axis. Because if you look, A is 1 unit from the y-axis, and X is 1 unit. And B is 3 units from the x-axis, and Y is 3 units from the y-axis. Y-axis. So our line of reflection here is the y-axis. Now if I wanted to describe what transformation would map them onto each other, I would just say a reflection, right? That's the type of transformation. And you always have to state the line of reflection. I said that before. Remember, at the beginning of the lesson, there always must be a line of reflection. All right? To reflect an object, you must have a line of reflection to reflect over. So, to map these onto each other, it's a reflection over the y-axis maps triangle ABC onto triangle XYZ. Now the next question here is, you should be familiar with this, is triangle ABC congruent to triangle XYZ? Explain using the properties of rigid motions. Well, the answer is, are these two congruent? Yes. And how do I know they're congruent? The reason is, I'm able to map them onto each other using a reflection. So a reflection over the y-axis maps triangle ABC onto triangle XYZ. A reflection, I know you're getting used to this by now, is a rigid motion, and rigid motions preserve the side lengths, and angle measures. I know, you know this already. And congruence means the length of the sides are the same and the angles of the sides of the two shapes are the same. So since I know that the side lengths are the same, the angles are the same, and these map onto each other, they must be congruent. So that is the sentence that proves that these two are congruent. They map right onto each other, all right, and the sides and angles are the same. All right, for the final part of this lesson, once again, I'm going to pull off the coordinate plane. So this is reflections without the coordinate plane. We've done it with the coordinate plane, and remember, that tells you where the lines of reflection are. Here, we don't use numbers, right? There's no like y-axis or x-axis. But you still have to find the line of reflection to be able to figure out how to map things onto each other. So for this one, we're going to describe a transformation that would map pentagon ABCDE onto pentagon FJIHG. So how do I map these onto each other? Okay? Well, first, just find the line of reflection. What are they reflecting over? Well, I think it's pretty clear. It's this line in the middle. So this is line XY. Okay? Now, to describe this transformation, what I would say is that this is a reflection, and you always have to state over the line which line you're reflecting over. So a reflection over XY, we're being specific, maps pentagon, and I'm just going to draw a crappy pentagon here, ABCDE onto pentagon, once again, hopefully you could draw a better one, FJIHG. Alright, and the main thing here is this. You're finding the line of reflection, and you're always stating that in your description. So let's try this next one. We want to describe a transformation that would map triangle ABC onto triangle DBC. Alright, so the first thing you have to do is figure out where's that line of reflection. Where does it flip over? And that is right over here. This line right here. Right? If I flip ABC over this line, they'll go on to BDC. Now what should we call this line of reflection? Well, there's 2 points on that line, and so we'll call it line BC. So to map these onto each other, these triangles, I'll say a reflection over line BC maps triangle ABC onto triangle DBC. Okay? And I just want to be clear here. I said the reflection and the line it goes over. And for the last one, this is where it's going to get a little fancy. We need to describe a series of true transformations that will map these two triangles onto each other. Now, what two transformations are we going to use? Well, I'll show you because I like you. Now, to get these, we first want to get these two triangles next to each other. That's our strategy. So the first thing I'm going to do is I'm going to use a translation. So let's map T onto X, right? I know T and X, those are both less, they correspond to each other. So I'm going to use line TX to translate along. So let's just do that. I'm going to translate along line TX. Like, work. Why didn't you take the triangle? Okay? So we go along, line TX, like so. Okay? Oh, cool. Look at that. So I just translate along TX. Let's write that. So first, a translation along TX. Okay? Now that they're right next to each other, so use the translation to get next to each other, I'm going to find my line of reflection. And just like in the previous example, my line of reflection is right here in the middle, right? If I flipped over this line, they would map onto each other. Okay? So first it's a reflection along TX, and then a reflection over, and my line of reflection is XC. Will map triangle LFT onto triangle YZX. Alright, so there you go. Sometimes you gotta do two. So that's it for this lesson. Remember, lines of reflections are key. And the second thing is, are cats meowing so cute? Like, OMG.